So, good morning, ma'am. Good morning, classmates. I'm Ben Saladis, the reporter of Chapter 3, Lesson 6, which is the human activities. So, let's start. Human activities contribute to climate change. The largest known contribution comes from the burning of fossil fuels, which releases carbon dioxide gas to the atmosphere. So, like coal, oil, and natural gas are examples of fossil fuels that, when burned for energy or transportation, cause the release of CO2 or the carbon dioxide. A phenomenon called the greenhouse effect occurs when heat from the sun is trapped by this gas, raising global temperatures. So, greenhouse gases and aerosols affect climate by altering incoming solar radiation and outgoing infrared thermal radiation that are part of Earth's energy balance. Changing the atmospheric abundance or properties of these gases and particles can lead to a warming or cooling of the climate system. So, when the sun's energy reaches Earth, some is absorbed and then re-emitted as heat. Greenhouse gases trap some of this heat, preventing it from escaping back into space. This warms the Earth, a process known as the greenhouse effect. Aerosols can influence cloud formation, affecting the Earth's albedo, the amount of sunlight reflected back into space, which can either cool or warm the planet, depending on the type of cloud and its location. So the human impact on climate during this era greatly exceeds that due to known changes in natural processes. Human activities result in emissions of four principal greenhouse gases. The first is the carbon dioxide. Like deforestation, releases carbon dioxide and reduces its uptake by plants. The second is the methane. It's related to agriculture, natural gas distribution, and landfills. Nitrous oxide is emitted by human activities such as fertilizer use and fossil fuel burning. The fourth is the halocarbon gas. Concentration have increased primarily due to human activities. Principal halocarbon include the chlorofluorocarbons, which were used extensively as refrigeration agents and in other industrial processes before their presence in the atmosphere was found to cause stratospheric ozone depletion. So, the abundance of chlorofluorocarbons gases is decreasing as a result of international regulations designed to protect the ozone layer. So, according to my research, the international regulations designed to protect the ozone layer has been or have been successful in decreasing the abundance of CFC gases. This has mitigated the harmful effects on the ozone layer and contributed to environmental preservation. So, halocarbons released by human activities destroyed ozone in the stratosphere and caused the ozone hole over Antarctica. While water vapor is the most abundant and important greenhouse gas in the atmosphere, only a small direct influence on the amount of atmosphere water vapor. So, for example, a warmer atmosphere contains more water vapor. When the Earth's atmosphere warms up, it can hold more moisture in the in form of water vapor. So this is because warmer air has higher capacity to hold water vapor before it reaches saturation. So human activities also influence water vapor through CH4 emission because CH4 undergoes chemical destruction in the stratosphere, producing a small amount of water vapor. And aerosol, the small particles present in the atmosphere with widely varying size, concentration, chemical composition. Some aerosol emitted directly into the atmosphere, while others are form emitted compounds. So, human activities, particularly through the emission of methane or the CH4, can influence water vapor in the atmosphere. Methane undergoes chemical destruction in the stratosphere, which produces a small amount of water vapor. Additionally, aerosol, which are small particles present in the atmosphere, can also affect water vapor levels. Aerosol contain both naturally occurring compounds and burning have increased aerosol containing sulfur compounds, organic compounds, and black carbons. So, aerosols contain a variety of compounds including naturally occurring ones and those generated from burning activities. Increasing burning has led to an increase in aerosol containing sulfur compounds, organic compounds, and black carbon. This aerosol can impact the concentration, size, and chemical composition of water vapor in the atmosphere. So human activities such as surface mining and industrial process have increased dust in the atmosphere. IPCC 2017. So according to the IPCC, or the Intergovernmental Panel on Climate Change, in their 2007 report, human activities such as surface mining and industrial process have increased the amount of dust in the atmosphere. The IPCC report states that human activity, which alter the composition of the global atmosphere, contributes to the increase in dust along with other factors. Dust particles in the atmosphere can have various effects, including direct radiative forcing, which can lead to a cooling effect. On September 16, 1906, an international treaty aimed to regulate the production and use of chemicals that can contribute to ozone layer depletion, Britannica 2017. So the treaty has been successful in reducing the production and consumption of ODs such as chlorofluorocarbons and halos, which were commonly used in various industrial processes and products. The efforts under the Montreal Protocol have contributed to the recovery of the ozone layer and have been regarded as a significant environmental achievement. And that would be all. Thank you, ma'am. Thank you, classmates.